Finishing up our trig equation lesson on 7.3, as we look at this second to last problem, 3 cosine of theta plus 3 is equal to 2 sine squared of theta. At first, this might seem like it's a typo. It's very similar to our previous problem, which was a quadratic. However, we have a cosine, we also have a sine squared, so we have two different trig functions. A little bit of review off to the side here. I think we all could agree quickly that sine squared plus cosine squared will equal 1. What we can do, though, is solve for sine squared to get that sine squared is equal to 1 minus the cosine squared of theta. Similarly, we can also solve to get cosine squared of theta is 1 minus sine squared of theta. Now, why might we want to do that? Well, if you'd like to see, perhaps, if this could be solved as a quadratic, you could take this right-hand side and say, well, let's rewrite sine squared as 1 minus cosine squared. Distributing a 2 then, we'd have 2 minus 2 cosine squared of theta. This left side, we'd have 3 cosine of theta plus 3. Moving everything to the left side, we'd have 2 cosine squared of theta plus 3 cosine of theta. If I were to subtract a 2 from both sides, I'd get plus 1. And here we go again. We can more or less view cosine of theta as if it were temporarily represented by w. And if so, it would be a much friendlier quadratic. A quadratic that would factor into 2w plus 1 and w plus 1. Solving here, 2w plus 1 equals 0, meaning w would be negative 1/2. Here w plus 1 would equal 0, w would equal negative 1. But this is really saying that cosine of theta is negative 1/2, and that the cosine of theta would equal negative 1. Now again, we have very specific boundaries. Cosine is only going to be looked at between 0 and 2 pi, one trip around the unit circle. Cosine is negative actually in the second and in the third quadrants. Cosine has a value of 1/2 with a reference angle of pi over 3. So in this second quadrant, we could say theta would be 2 pi over 3. And in the third quadrant, we'd have 4 pi over 3. Similarly, cosine could be negative 1 at pi. We wouldn't say plus 2 pi k here because we're just going to go between a 0 and 2 pi. For our very last problem, let's take a look at this left-hand side. If we had 5 sine x plus x, and down here we could just type in a 3. I think immediately sometimes kids will point out that it appears that we don't have any specific angle boundaries. We're not told to look only between 0 and 2 pi. Let's do a zoom trig and just see where we are. You can see here is our sine wave, and you can see pretty much it looks like we are yielding 3 distinct answers in this regard. You might wonder if perhaps we're going to get more, and that would be a fair question. As we were opening this up, maybe go out to 10 radians, see if perchance maybe we're going to get more intersections, and it's always in the realm of possibility that we will. Sure looks, even as you begin to trace, when you have x plus the sine of x, you can see that as we venture further and further out, that our y values are getting to be considerably larger and larger and larger. So it looks like we'll have 3 distinct solutions here, and we'll find them by the intersect tool. We'll go to, say, 2 decimal places. So the intersect will say, here's my first function is sine, here's y equals 3, guess. You can see we're at about 5.71. So that's one solution in radian measurements. Let's see, we can go to second calculate, use the intersect tool. The sine wave, you can see we're coming right over here. You don't even have to get this close. You could have gone the other route, getting closer on the y equals 3 curve. When it says guess, just hit enter one more time. It looks like we're at 3.18. And it looks like we have one final intersection. Looks like it's going to be right over here. We'll just hit second calculate and intersect one final time. And again, you don't have to do what I'm doing, tracing to the left, but you certainly can. I'm on my first curve of the trig function, 5 sine of x plus x. I'll just hit enter. Hit enter for y equals 3. We're awfully close right here. You could see we'd be at 0.52 roughly. If you're ever worried about whether we intersect to the left, though, you can just begin to trace over and notice that your y values on the sine wave are going to drop off. You won't be getting close to 3 at all. So this is why they didn't give us any prescribed boundaries. There'd only be 3 solutions. Our homework for over this break is a little bit longer, 11 through 91 the odds on page 465. But hopefully it won't take long. Some problems are quite a bit shorter than others. Okay, wish you well.